Hi everyone. I'm very excited to be speaking with you all today, and hopefully you're enjoying all the amazing sessions and you're learning a lot. And I do hope that you had a chance to check out our amazing co-founder Ajit. He was a keynote speaker here as well, Aviram Shmueli. And I hope that you will learn from this session too. So let's get started. Today I want to talk about how you can defend your cloud native apps against OWASP Serverless Top 10. Now, securing your web application could be a very hard thing to do if you don't know how. But luckily, we have organizations like OWASP that really points out the common threats and the right open source tools that we can utilize in order to make our application much more secure. Before we dive in, I think that we need to do a quick introduction. So my name is Probstein. I'm a solution engineer at JIT. I've been a full stack engineer for many years, actually, and I've joined JIT about 10 months ago as a full stack engineer. And after about 8 months of this position, I've decided that I want to do a little bit of a shift and become a solution engineer. I'm also studying for my bachelor's degree in biotechnology, and that's about me. I do want to tell you about JIT as well. So JIT is an open DevSecOps orchestration platform. We're helping modern dev organizations own their application security without hurting the dev velocity. We're automating the best open source security tools. We're integrating security across your entire lifecycle, code, infrastructure, CI/CD pipeline, and runtime. And of course, JIT is 100% built in serverless. So you probably wonder how we secured our platform with the hundreds of Lambda functions, the event bridges buses, the DynamoDB tables, we have SQS queues, we have API gateways. Well, we realized that we must have a battle plan. We need to understand what are the risks that we're up against and we need to know what tools we want to use, right? The soldier in this battle. So we started by looking for an existing list of top security risks for web application. We found out that there is one popular organization that was posting and sharing a list every year. The name of this organization is OWASP. OWASP Top 10 is a great starting point for the battle plan, and we will shortly see how. Before we jump into OWASP Top 10 lists, I want to talk about the basics. What is the difference between a classic app and a modern app? And specifically, how is this different affects us? Let's take a look at the shared responsibility model, and we'll start with a classic app. AWS is recognized as a highly secured environment, right? Our infrastructure is monitored 24/7. It offers a lot of capabilities to improve resilience, and it allows encryption in the data that is flowing across the network before it's leaving our site. Since very early days when customers build secure application on AWS, we've been using the shared responsibility model. We can see here that the customer, which is us, is in charge of stuff like traffic protection and server-side encryption. This is mostly relevant for serverful, but what about serverless? With serverless, we're expected to take care of a much smaller part of the stack. We have to rely on years of expertise, of knowledge, and best practices. Everything is available at our fingertips. The entire part of infrastructure has been removed from us, but as you can see here, there are still some part of this shared responsibility model that we need to take care of. This is exactly where OWASP Top 10 come to our help. It doesn't matter if you're designing any application, not only serverless. I do want to give you a bit of a background on OWASP. So OWASP is a nonprofit organization that was founded in 2001 with the simple goal of helping security experts protect their web application from cyber attacks. They released multiple popular open source tools like Zap, and they also released some key publications like DSOM and the OWASP Top 10 list. They've been updating this list yearly since 2003, and this list offers ranking and some remediation guidelines for the top risks for web applications. With the years, they created even more dedicated lists for serverless apps, mobile apps, API, CI/CD pipeline, and so much more. Today, we will focus on the OWASP Top 10 for serverless. This is the QR code. It would take you straight to the project page of OWASP Top 10 for serverless. I'll wait for a second just so you'll have the chance to scan it. And if you don't, then you can find it pretty easily on Google. So I think that this was enough time for you to scan it. And now we'll quickly go over the top 10 list items just to cover that and get you guys started. The first item is broken access control. This describes the risk of compromising privileged lambda functions, which could lead to unauthorized access to resources and data leakage. Sensitive data exposure means that we're storing sensitive data in plain text or even using weak cryptography on any storage. This is extremely common, as well as writing data to /temp directory and not deleting it after. This could lead into sensitive data leakage. The third one is injection. This describes the risk of compromising apps through crafted payloads that are being injected in the user input through various sources. It could be emails or S3 buckets. XML external entities. A successful XSC attack in serverless applications could lead mostly into function code leak and other sensitive files that are located in the environment, like environment variables or files under /temp. Security misconfiguration described the very common risk of application security being misconfigured, like over permissive functions or lack of security hardening. Moving to using components with known vulnerabilities. This described the common supply chain attack risk of using third-party libraries with known vulnerabilities. This could lead to various breaches as well. Cross-site scripting, XSS. This described the risk of untrusted input that is being used to generate data that ends up in the DOM without performing proper escaping. For web services, this is typically to extract untrusted data from a JSON. Insecure deserialization described the risk in the fact that most functions use third-party libraries in order to handle the deserialization and serialization of data. This usually results in running arbitrary code that could eventually lead to data leakage, and in severe cases, even resource and account control. Broken authentication, having access to functions without authentication can lead to sensitive data leakage and potentially could also lead to breaking the system's business logic and flow of execution. The last item is insufficient logging and monitoring. This refers to lack of proper monitoring through logs and incident response processes, which basically means that we're allowing attacks to stay undetected. So in order to make it easier to remember all those risks, let's split them into security domains. So we have identity and access, we have code, we have data, and we have logging and monitoring. All right then. So this was kind of an overview, and hopefully you're alive. Now that we have the foundations and the basics, I hope that it's making more sense in terms of what is the OWASP top 10 list, and you have a better understanding of the risks. Now, for the sake of time, we won't describe in details all those risks. I will focus on these 7, and for each of them, we will talk about the best open source tools and services that we can use. We're going to talk about broken access control. We're going to talk about sensitive data exposure, injection, using components with known vulnerabilities, insecure deserialization, and broken authentication, and lastly, insufficient logging and monitoring. All right, so how do we approach this? The easiest way to go over a list is to work by flow. For every item, we need to understand the risk. We need to state what we need to do in order to protect ourselves from it and to prevent it. We need to find the best tool to help us in our task. And for the next level, we need to automate, but we'll get to this as well. So OWASP already did the first 3 steps for us. So all we have to do is learn and implement. Let's start with the first topic that we're going to dive into, and this is broken access control. I think that this is clear to all of us that we're in charge of our applications authorization to other parts of the system, including, of course, our data. If you don't do that, then you're risking your serverless apps of modification or deletion of data, execution of unauthorized code, data leakage from cloud storage or databases. The basic requirements for my app should include strong authentication. We need to ensure that our functions are running with least privilege, and we need to have regular access logs audits. So we need to find a tool that checks for least privilege IAM roles. Here are some great tools for the rescue. I'm not going to describe all of them, but just for example, PMapper, Principal Mapper. This is a script and a library that identifying risk for the configuration of IAM. We have Policy Sentry. This is AWS IAM List Privilege Policy Generator, Auditor, and Analysis Database. So moving on to the next item, injection. Lack of input validation could lead to exploits like SQL injection. We're risking privilege escalation, execution of unauthorized code, and data leakage. What do we need to do in order to protect ourselves? We need to validate the data input. We need to ensure that our functions are running with least privilege, and we need to ensure that we're monitoring our functions at runtime. So we need to find a tool that checks that we're not vulnerable to traditional injection attacks, and we need to make sure that our functions don't have wide privilege scopes. A few cloud-native services that can really help us here: IAM Access Analyzer to apply the least privilege principles to our functions. We have CloudWatch Logs and CloudTrail for the monitoring part. And if your functions are accessible externally through API Gateway, I highly advise you to use DAST tool, like the very popular OWASP Zap, for pen testing. Moving to using components with known vulnerabilities. This one is a well-known one, yet most of the public breaches are still related to it. The risks here are denial of service attacks, malware and ransomware attacks, and data breaches. In serverless apps, you don't need to deal with hardware, so no OS patches required here, but you do still need to ensure that you don't use dependencies with known vulnerabilities. So we basically need to scan our libraries for vulnerabilities. Here are a few open source tools that can help us detect malicious libraries in our code. So we have OSV Scanner. This is a recent tool that is maintained by Google and supporting most of the package managers. We have NPM Audit for NPM packages. We have Nancy for Go, and we have Dependency Check, which is mostly for Java. The next item is insecurity serialization. Dynamic languages like Python and Node.js, together with the common usage of JSON, which is a serialized data type, this could make deserialization attacks a little bit more common in serverless world. The fact that most functions use third-party libraries to handle the serialization and deserialization of data could introduce such weakness to our serverless app. Now, insecurity deserialization usually results in running arbitrary code that could eventually lead to data leakage, and as I said in the beginning, in severe cases, even resource and account control. How to prevent those attacks? We need to validate serialized objects that are originating from untrusted data like cloud storage, database, emails, notification, APIs. We need to review third-party libraries for known deserialization vulnerabilities. And it is also a good practice to monitor deserialization usage and exception to identify possible attacks. So we need to find tools that checks the serialized object and scans the code libraries for vulnerabilities. Well, the SCIE tools that I've mentioned before can really help us here as well. OSV Scanner, NPM Audit, Nancy, and Dependency Check. And the DAST tool, we have OWASP Zap for the rescue of that. All right, so how's everyone doing? Are we all okay? Awesome, because we've covered 4 items by now. We've covered broken access control, we've covered injection, using components with known vulnerabilities, and insecurity serialization. We have 3 more to go, so I hope you're awake and ready for the next one. The next one is broken authentication. Broken authentication is usually a result of poor design of identity and access controls. In serverless architectures, we have multiple potential entries. We have services, events, triggers. Things can get a bit more complex here. We're risking data leakage and potentially broken execution flow. So we need to make sure that we're not allowing threats through authentication. But how do we do that? So we need to make sure that we don't have unauthorized endpoints. We need to make sure that we're managing our users correctly. Of course, our infrastructure must use central authentication method for inter-services, which is basically mean that we need to use authentication inside the services as well. If something happens, we want to make sure that the data flow is secured. Lambda and services should require authentication, and we need to verify that we don't have any unmanaged resources like S3 buckets or IP addresses. By doing this, we're making sure that nothing can penetrate our app from the outside world. So we basically need to find a tool that checks for runtime misconfiguration. Prowler is a great open source security tool that performs AWS security best practice assessments, audit, incident response, continuous monitoring, and hardening. Using Prowler, we get the runtime misconfiguration scan, and we get constant monitoring and logging. This is extremely important because if something does happen, we need to know about it. We want to have a log to look at so we can find the issue when it happens, and we want to handle it. Logs also make our research easier so we can find a solution faster. Here as well, OWASP Zap can really help us with detection. So we have Prowler and Zap now. This is about the broken authentication, and we're moving on to sensitive data exposure. Sensitive data exposure is a concern in serverless architecture as in any other architecture. Most of the methods that are used in traditional architecture, such as stealing keys, performing man-in-the-middle attacks, and stealing readable data at rest or in transit, all still apply in serverless application. But the data sources might be different here. Instead of stealing data from a server, the attacker can target cloud storage like S3 buckets and database tables. So we need to make sure that our sensitive data is not accessible from public resources. We need to store as little as possible, which means we're only storing what is actually necessary. We need to make sure that we're encrypting the stored sensitive data. We need to encrypt the data that is flowing in runtime. So we want a tool that searches for hard-coded secrets, and we want a tool that checks that the traffic is encrypted at rest and in transit as well. I will show you 3 tools that can really help us here. And the first one is GitLeaks. GitLeaks detects multiple types of secrets like API keys and tokens. It searches in Git history, and it can be easily integrated in the CI/CD. And the other 2 are Prowler and Zap that I've mentioned before. So again, we see that some tools actually help us with more than one threat. Moving on to the last item of the list today. So this is insufficient logging and monitoring. The risks are fairly simple here. If your monitoring is lacking, attackers may stay undetected. Not having an incident response process may delay the breach remediation, and this is making the data loss even more catastrophic. So in order to handle those risks, we need to have enough logging both for our app and our infrastructure. This will allow you to investigate the issue when they will occur. And in addition, having a basic incident response process in place really help us saving crucial time when there is an incident. So how can I be proactive and prepare myself for these attacks? I need to find tools that provides logging for my app and my infrastructure. In the application level, I need to add application logging for system and admin events. So in order to track behaviors like privilege escalation happening in my app. For my infra, we can leverage several cloud native services like Amazon Detective, CloudWatch Logs, and CloudTrail. This will help us keep track of requests in the system and use the logs for investigation. And Prowler can help us here as well. Awesome. So we've covered the 7 items. So we've covered broken access control. We've covered injection, using components with known vulnerabilities, insecurity serialization, sensitive data exposure, broken authentication, and insufficient logging and monitoring. I do hope that now you have a better understanding on the way that we look at the list, and you saw some examples of great open source tools and services that can really help us. So what are the takeaways from this talk? How can I secure my serverless app? Well, in order to not reinvent the wheel, I would advise you to start with a security framework. Today, we went through the OWASP Serverless Top 10, but there are other great checklists that you can check out and protect yourself using them. If you're a startup, the SSB is a great place to start. The CIS benchmark provides a large number of checks. And finally, the AWS well-architected framework that includes a very comprehensive list of security requirements that you definitely want to check out. Remember, security is not a one-time checkbox that you can just check. This is a journey. You need to continuously monitor your app and your environment. Now, if you really want to take this to the next level, then you have to automate. And if you're looking for help to automate all this, well, guess what? JIT can help you. We codify security plans and automate them. Our engine orchestrates prepackaged open source, commercial, and cloud native tools across your entire environment. So we're providing you with a one-stop shop for your product security at the tip of your fingers, including, of course, success KPIs. If this is interesting to you, if you're intrigued and you want to know more, please check out our website. This is the QR code to take you there, or just visit us at jit.io. I really appreciate the opportunity to talk with you guys today, and I'll happily answer any questions you may have offline. Please reach out to me. This is my email, and thank you everybody for your time.